In this video, let us learn to calculate refractive index of the material of the convex lens by forming Newton's rings. Before we proceed to learn the calculation, let us get to know some basics of Vernier microscope. The least count of Vernier microscope is 0.001 centimeter or 0.001 into 10 power minus 2 meter. That means in this experiment all the readings are taken to a precision of 3 decimal points. For example, in Vernier microscope we have two types of reading. One is mind scale reading, another one is Vernier scale coincidence. If your mind scale reads 8.50 into 10 power minus 2 meter and your Vernier scale coincidence is 35 divisions, then the Vernier scale reading will be calculated as Vernier scale coincidence multiplied by the least count. So it is 35 into 0.001 into 10 power minus 2 meter. So your Vernier scale reading will be 0.035 into 10 power minus 2 meter. Then the total reading can be calculated as mind scale reading plus Vernier scale reading. Our mind scale reading here is 8.50 centimeters plus Vernier scale reading is 0.035 centimeter. So the total reading is 8.535 into 10 power minus 2 meters or centimeter. This is how we have to find the total reading. Okay, now let us find the radius of curvature for the surface 1 of the given convex lens. So, how to calculate the radius of the curvature of a convex lens by forming a Newton's ring is explained in my previous video. Anyway, I will explain it again here. So, the readings will be taken for every 3 rings or for every 5 rings. Here, it is our choice. Here we have taken the readings for every 3 readings and n for left and n for right, and we have taken the readings up to the order of n plus 21. For the n plus 21, see, the mind scale reading is 5.45 and the Vernier coincidence is 11. So the total reading is 5.461. And for n plus 8 it is 5.40 and Vernier scale coincidence is 35. So the total reading is 5.435. In the same way, we have to calculate the total reading for the left and for the right readings. I mean for the readings in the right side of the ring. Then let us find the diameter of the ring. The diameter of the ring is found by subtracting the total reading in the left minus the right reading. See, for the first nth reading, the diameter of the ring 2 rho is obtained by subtracting 5.205 minus 5.015. So the answer is 0.19. For the n plus third reading, the diameter is 5.274 minus 4.975, which is 0.299. In the same way, we can calculate the 2 rho. For the n plus 21, it is 5.461 minus 4.773. So you get 0.688. So we have found the diameter. Then we have to get the radius. We all know how to get the radius. Divide the diameter by 2. So 0.19 divided by 2 will give us 0.095. 0.299 divided by 2 will give us 0.1495. In the same way, let us calculate the radius for the radius till n plus 21. So for the n plus 21th ring, the diameter is 0.688. Dividing by 2 we get the radius 0.344. Then let us square this radius. For nth radius of the nth ring, that is 0.095. When we square it, we get 0.0090. For n plus third reading, it is 0.1495. Square it, you get 0.0224. So you square the radius till n plus 21, 0.11834 for n plus 21. Then we have to find S. S is nothing but it is rho n plus mth, the rho square of n plus mth reading minus rho square of nth reading. That is mth reading means you can take the difference for, a difference for any number of rings. M represents the difference. You can find the difference for 3 rings or for 6 rings, for 9 rings, 15 rings. It's up to us. Here the difference is taken for the 12th ring. See, n plus 12 minus n. So that is 0.0792 minus 0.0090 gives us 0.0702. This is the first combination. Second combination is n plus 15 minus n plus 3 will also give us a difference of 12 rings. So 0.0918 minus 0.0224 will give us 0.0694. In the same way, we will get the values, 4 values. So you could see in the last column, there are 4 values, 0.0702, 0.0694. Almost they are almost consistent. You could see in the last column, all the 4 readings are consistent. So we can take the average of these 4 readings and mean rho square n plus 12 minus rho n square equal to 0.06865 into 10 power minus 4 meter. This 10 power minus 4 comes because we are squaring the radius. The radius is in 10 power minus 2. When you square the radius, you will get 10 power minus 4. I have not detailed the calculation of this table because this has been already explained in another video in a detailed manner. So you can go through that video to know better. So this is for one side. Then we will flip the convex lens. Then flipping it, we will get it for we will do it for surface 2. For surface, radius of curvature for the surface 2, that is R2. Again, the calculation for this will also be done in the same manner as the previous table. Again, we have got 4 values in the last column. In the last column, you could see the values are not consistent. Only the 3 values are consistent. You could see in the last column, the last row, the rho square n plus 12 minus rho square n is 0.084. So it deviates from the other value. While you take an average, you better leave this value and take an average. So taking the average of the other 3 values gives us 0.061 into 10 power minus 4 meter. So let us find R1 and R2. So rho square n plus 12 minus rho n square for surface 1 is 0.06865 into 10 power minus 4 m, and the wavelength of the sodium vapor lamp used is 5893 into 10 power minus 10 meters. So and the formula to calculate the radius of curvature is rho square n plus m minus rho square n divided by m lambda. Here the difference is found for 12. So in place of m, we have substituted 12. The rho square n plus 12 minus rho square n value is already we have calculated. It is 0.06865 into 10 power minus 4. The whole thing divided by 12 into 5893 into 10 power minus 10. So bringing the 10 power minus 10 in the denominator to the numerator, we get 0.06865 into 10 power minus 4 into 10 power 10. and the denominator is multiplied, that is 12 into 5893 is multiplied, we get 70716. Then divide the numerator by denominator, we get 0.9708 into 10 power minus 6. In the numerator already there is one 10 power minus 4 and 10 power plus 10, that will give you 10 power plus 6. So this 10 power minus 6 and 10 power plus 6 will get cancelled. See, when you divide 0.06865 divided by 70716, you will get a exponential value in the calculator. Don't miss that exponential value. So this 10 power minus 6 and 10 power plus 6 will get cancelled. So the radius of curvature of the convex lens for the surface one is 0.9708 meter. Generally, the radius of curvature for a convex lens will be around 1 meter. We have also obtained a value closer to 1 meter. Okay, let's calculate the radius of curvature for the second surface R2, and rho square n plus 12 minus rho n square for the second surface is 0.061 into 10 power minus 4 meter, and the lambda we know 5893 into 10 power minus 10 meter. Substituting all the values and calculating as before, we get the value of R2 as 0.8626 meters. Generally, the radius of curvature of the surface 1 and surface 2 will be almost nearly, they will be closer to each other, there will be a slight difference only. So here we have got the value of R2 as 0.8626 meter. And the focal length of the long focus convex lens used during the experiment is obtained by autocollimation method, and the value of the f is 90.4 into 10 power minus 2 meter. Okay, now let us calculate the refractive index of the material of the convex lens used for forming the Newton's ring. So f is mentioned as 90.4 into 10 power minus 2 meter, R1 is 0.9708, R2 is 0.8626. The formula to calculate mu is 1 plus 1 by f into R1 by R1 into R2 divided by R1 plus R2. Actually, in the formula a meter is written there, it is not meter. Refractive index do not have any unit. So 1 plus, substituting the value, 1 plus 1 divided by f value is 90.4 into 10 power minus 2, R1 value is 0.9708 into 0.8626, the whole thing divided by 0.9708 plus 0.8626. In the next step, let us multiply the numerator and add the denominator. So we get 1 plus 1 divided by 90.4 into 10 power minus 2. Multiplying these two value R1 and R2 value, we get 0.8374, and adding these two value we get 1.8334. Then 1 plus the 10 power minus 2 in the numerator has been taken to the denominator has been taken to the numerator, so it becomes 10 power 2 divided by 90.4, and dividing 0.8374 divided by 1.8334 gives us 0.4567. Then divide this 0.4567 divided by 90.4, we will get 0.005051, and multiply that value by 10 power 2. So we will get 1 plus straight away either you can multiply this by 100, or this will give us, or you can write it like this, 10 power 2 into pulling this 10 power minus 2 from it will give us 0.5051, or straight away you can multiply in the previous step itself to get 0.5051. So 1 plus 0.5051 will give us 1.5051. So we have got the value of refractive index of the material of the convex lens as mu equal to 1.5051. Generally, convex lenses are made out of glasses like a crown glass or flint glass, and The refractive index for the crown glass or flint glass will lie between 1.5 to 1.6. We have also got the value closer to 1.5.